Right then, from that glowing box that used to sit in the corner of the living room to these incredible ultra-thin 8K screens we have today, the television has just completely reshaped our world, hasn't it? But how did we actually get here? Well, let's explore that incredible journey of invention, innovation, and some of the unsung heroes who made it all possible. So, to kick things off, let's think about a name we all know, YouTube. It feels so modern, doesn't it? A proper product of the internet age. But that second word, tube, is actually a direct link, a little breadcrumb trail, right back to the very origins of television. It's a fantastic bit of tech history hiding in plain sight. And there you have it. The tube was the cathode-ray tube, or CRT for short. Now, this wasn't just another component. For decades, it was the heart of the television. It was this big, heavy glass vacuum tube where a beam of electrons literally painted the picture line by painstaking line. So, when people talked about watching the tube, they were being completely literal. Okay, before the TV tube could even exist, a much more fundamental problem had to be solved. Picture this, it's the 19th century, and inventors are just completely stumped. I mean, sending sound down a wire for the telephone, that was one thing. But how could you possibly transmit a whole complex picture? It must have seemed absolutely impossible. The breakthrough came when they stopped thinking about the image as one big thing. The solution was something called image scanning. You can think of it like reading a book, really. You don't absorb the whole page at once, do you? Your eyes scan from left to right, line by line. Well, the inventors realized they had to do the exact same thing with an image. Break it into lines, turn each tiny speck of light into an electrical signal, and then send it down the wire one piece at a time. And you know what? The first attempts were wonderfully mechanical. I love this. In 1842, a clockmaker, of all people, named Alexander Bain used a swinging pendulum with a needle on it to scan an image. It was painfully slow, but it proved the concept worked. Then, about 40 years later, Germany's Paul Nipkow created this brilliant contraption, the Nipkow disc. It was just a simple spinning disc with holes arranged in a spiral. As it spun, each hole would scan one line of the image. A bit clunky, for sure, but it was the absolute foundation of television. But there was a catch. These mechanical systems, as clever as they were, had a pretty low ceiling. I mean, spinning discs can only move so fast, right? This meant the pictures were dim, incredibly fuzzy, and they just couldn't capture smooth motion. To get to television as we know it, they had to get rid of the moving parts. And this is where the story takes a pivotal turn, and we head over to Japan. In 1926, an engineer by the name of Kenjiro Takayanagi realized that the future wasn't in more complicated machinery, but in harnessing the power of the electron itself. So what Takanagi did was create this hybrid system. He still used a mechanical Nipkow disc to capture the image, but, and this is the crucial part, he sent that signal to a cathode-ray tube to display it. He successfully transmitted and showed the Japanese character E on his screen. It was the very first time a CRT had ever been used as a television receiver, a truly monumental step towards a fully electronic system. And this was just a massive leap. Honestly, the technology went from physical, clunky, spinning discs and motors to invisible, lightning-fast electron beams. The difference was like night and day. It made clear, reliable broadcasting actually possible and turned television from a fuzzy little curiosity into a powerful new medium. So, the electronic concept was proven. Brilliant. But a prototype in a lab is a very, very long way from a television in every single living room. The next great challenge was a practical one. How do you take this incredibly complex, fragile technology and turn it into a reliable consumer product that an ordinary family could actually afford? And the answer wasn't just about making the big picture tube better. No. The real magic, the innovation that truly brought television to the masses, happened deeper inside the box. It all came down to a few small, often overlooked components that made the whole system just work. The key was a component called the ferrite core. Now, inside the TV, it played two vital roles. First, the deflection yoke used it to create a super precise magnetic field that would steer the electron beam, painting the picture 25 to 30 times a second. At the very same time, the flyback transformer used it to generate the enormous voltages needed to get the screen to glow in the first place. Without these reliable little parts, TVs would have just stayed far too expensive for the average home. And the results were just staggering. Let's take Japan, for example. Broadcasting kicks off in 1953. Just 6 years later, the live broadcast of the Crown Prince's wedding creates this massive surge in demand. Then, in 1964, the Tokyo Olympics does the exact same thing for color television. These huge cultural moments, made possible by affordable technology, turned the TV from a luxury into a household necessity in just over 2 decades. Amazing.
For 50 years, the cathode-ray tube was king. It reigned supreme. But it had its limits. It needed a deep chassis to house the electron gun, which is why old TVs were so bulky. They were heavy, made of thick glass, and they used up a lot of power. The very technology that started the revolution was, well, now holding it back.
So the solution was radical, but actually quite simple. To move forward, television had to abandon its own origin story. It was time to get rid of the tube. And once it was free from the tube, the technology just accelerated dramatically. Flat panel displays like LCD and plasma completely liberated the television's design, and this unleashed a digital explosion. You had satellite TV, high definition in the 90s, and eventually a complete switchover to digital broadcasting. And that is what paved the way for the incredible clarity of 4K and 8K, resolutions that were just unimaginable back in the age of the tube.
You know, this quote really sums it all up beautifully. That sleek, paper-thin screen you've got on your wall today looks absolutely nothing like your grandparents' television set. But the fundamental principles of scanning an image, displaying it with light, and relying on brilliant little bits of component innovation are a direct legacy of the work that began over a century ago. It's just an incredible arc of progress when you really stop and think about it. We went from a clunky spinning disc to a near-perfect high-resolution window on reality. It really makes you wonder, doesn't it? After a century of such radical change, what on earth will the screen of the future look like?